Geometric sequence C2, January 2009, number 9. The first three terms of a geometric series are k plus 4, k and 2k minus 15 respectively, where k is a positive constant. Show that k squared minus 7k minus 60 equals 0. So first thing, we know that they gave us in the given the first three terms of a geometric sequence. So they declared that this is a geometric sequence or series. So U1, let us name them. So U1 is k plus 4, U2 is k, and U3 is 2k minus 15. And remember that k is greater than 0, or it's positive number. Now, in order to show that k squared minus 7k minus 60 equals 0, we have to establish a relationship between the first three terms. So since this is a geometric sequence, therefore the ratio of the two consecutive numbers u2 over u1 equals r, where you replace the value of u2 and the value of u1, and you will get k over k plus 4. And at the same time, you know that u3 over u2 is equal also to the same common ratio r. Therefore, you replace the value of u3 and u2. Then you know that this is a geometric. Since you know that this is a geometric sequence, therefore you have a common ratio. So this common ratio, it means that r is equal to r. You replace the value of the what you found here and this one, they are equal to each other, two equal fractions. Therefore you cross multiply, and from here onwards you you do your algebra calculation. So k times k is k squared, then you multiply k plus 4 times 2k minus 15, you expand. After expanding, you take everything to one side, then you collect, and therefore you reach what they want us to find, which is k squared minus 7k minus 60 equals 0. In part B, they want you to show that k is equal to 12. So in order to find the k equals to 12, we need to take the quadratic equation that we already found and factorize it, or find using the quadratic formula the roots for this equation. So you either use delta, or you use your calculator, or you use the sum and product method to factorize in order for us to find the roots. So here I used the discriminant delta, or the quadratic formula. So after finding delta, which is b squared minus 4ac, calculating, you get 289, and the square root of 289 is 17. So k is equal to x minus square root delta, or sorry, b minus b minus square root delta over 2a, which is 7 minus 17 over 2, which is equal to minus 5. And here you have minus b plus square root delta over 2a, which is equal to 24 over 2, which is equal to 12. So they want us to find, or to show that k is equal to 12, and we did. And since k is greater than 0, so you have to reject the negative root that you found. Part C, they are asking find the common ratio of this series. So to find the common ratio of this series, you choose either one of these, either this one or this one, and you replace the value of k, which is equal to 12. Now since this k over k plus 4 is easier for us to calculate, and it will minimize mistakes. So you replace k here and you choose it, and you replace k here by 12, and 12 plus 4 is 16, so r is equal to 3 over 4. And the last part, which is part D, find the sum to infinity of the series. So the sum to infinity, you have to get the formula for that from the formula booklet, where it says that the sum of infinity is equal to the first term, which is a, over 1 minus r. So the first term, we don't have it, so we need to find it. And u1 is the first term, which is equal to 12 plus 4, which is 16. And therefore you replace r by 3 over 4. So you say 1 minus 3 over 4. 1 minus 3 over 4, common denominator, it's 4 minus 3 over 4, which is equal to 1 over 4. Here you have a division bar, therefore when you change it to multiplication, you flip the fraction. Therefore s to infinity is equal to 64.